Today we are going to discuss the chemical properties of alkyl halides. Generally, the alkyl halides undergo nucleophilic substitution reactions and elimination reactions. So, substitution is nothing but we have to replace one atom with another atom in the compound. So, which type of atoms or ions we are going to replace means we are going to replace nucleophiles. Usually, in an alkyl halide Rx, it dissociates as R plus X minus. Here, X minus is the nucleophile. That means halide ion is nucleophile in the alkyl halide. So in place of this nucleophile, we have to replace another nucleophile, that is a negatively charged ion. So such type of reactions are called nucleophilic substitution reactions, and hence the alkyl halides undergo nucleophilic substitution reactions. And the other type of reactions is elimination reactions. Elimination, it is nothing but we have to eliminate or remove a smaller molecule. So such type of reactions are called elimination. These are the two major type of reactions in which the alkyl halides undergo. So let us discuss detailedly about these reactions. Initially, we will discuss or we will study about the nucleophilic substitution reactions. The first one is reaction with aqueous sodium hydroxide or potassium hydroxide. So aqueous, this is very important. This solvent plays a very important role in getting the product here. So when an alkyl halide reacts with a base, aqueous base like potassium hydroxide or sodium hydroxide, so that a nucleophilic substitution takes place. That means in place of this halide, another nucleophile. So the another nucleophile present in our reagent is hydroxide ion, OH minus. That is to be replaced. So that in place of halogen, we have to replace OH, so that the product is an alcohol or OH is an alcohol. So alkyl halides reacts with aqueous base to give alcohol. Example. So it is very easy to write the examples if we know the general reaction. In place of R, you just write C2H5, that becomes ethyl. In place of X, you write bromine, it becomes ethyl bromide. So that the net product will be ethyl alcohol. This is the reaction with aqueous NaOH. Similarly, the reaction with moist silver oxide. Moist is nothing but moisture, that is water content. So hydrated silver oxide. So when alkyl halide reacts with moist silver oxide, again we will get an alcohol or OH. This is the general reaction. RX plus Ag2O gives rise to ROH plus AgX. And specific example. So as I said now itself, in place of R you write ethyl group, in place of X you write bromine. So that becomes a specific example. C2H5Br plus Ag2O gives rise to C2H5OH plus AgBr. This is very important. With moist silver oxide, alkyl halide gives alcohol. With dry silver oxide, it gives ethers. We'll discuss in later classes. So with moist silver oxide, it gives alcohols. Then reaction with alcoholic AgCN. Alcoholic AgCN. Here the solvent is alcohol. Alcoholic silver cyanide. So alkyl halides, when reacted with silver cyanide, alcoholic silver cyanide, we will get isocyanide. See here, isocyanide or NC. If in CN group alkyl group is attached to carbon atom of CN, then it is called cyanide, alkyl cyanides. If nitrogen is attached to the alkyl group, then it is called isocyanide. So that is the difference. In CN group, if carbon is attached to alkyl group, it is cyanide. If nitrogen is attached to alkyl group, then isocyanide. So with alcoholic silver cyanide, we will get isocyanides. Example, ethyl bromide gives ethyl isocyanide. Then reaction with alcoholic potassium cyanide. So that is silver cyanide, this is potassium. With potassium cyanide, we are going to get cyanide. See the difference here. With alcoholic KgCN, I will get isocyanide. With potassium cyanide, I will get cyanides. That is the difference between the reaction with alcoholic silver cyanide and alcoholic potassium cyanide. Then reaction with silver salts of carboxylic acid. Silver salts of carboxylic acid. How to write the formula of silver salt of carboxylic acid? Carboxylic acid, RCOOH. RCOOH. In place of hydrogen, you just write silver. It becomes a silver salt of carboxylic acid. When alkyl halide is treated with silver salt of carboxylic acid, this X and AZ is eliminated in the form of AgX. So that, see here, RCOO. In place of AG, we have written R. This is RCOOR. This is ester. So example, C2H5Br plus CH3COOAg. This is silver acetate or silver ethanoate. In place, we have to remove this AZ and Br. AzBr. In place of silver, I will write C2H5. This is C2H5. So C2H5 is nothing but ethyl, and this is acetate. Ethyl acetate. This is the reaction with silver salt of carboxylic acid. Then reaction with potassium nitrite, alcoholic potassium nitrite. So with silver salt of with alcoholic potassium nitrite, alkyl halides give alkyl nitrite. See, in NO2 group, if alkyl group or if the structure of NO2 is in this manner, that means if the oxygen atom is linked to alkyl group, this is called nitrite. If nitrogen is linked to alkyl group, this is called nitro group. See, if nitrogen is linked, nitro. If oxygen is linked, nitrite. So RX plus alcoholic KNO2, it gives nitrite. Nothing but alkyl group should be linked to oxygen. Alkyl nitrite. Alkyl nitrite. Example, RX in place of RX C2H5Br, then I will get ethyl nitrite C2H5O N double bond O, and the byproduct is KBr. And similarly, reaction with alcoholic silver nitrite. With silver nitrite, I will get nitroalkanes. So that nitrogen will be linked to the alkyl group. So this is the difference. With the potassium nitrate, I will get alkyl nitrate. With silver nitrate, I will get nitroalkane. And reaction with sodium alkoxide, that is alkyl halide. Sodium alkoxide formula RONA. So sodium alkox, this is sodium, this is alkyl group, this is oxygen, sodium alkoxide. So when alkyl halide is treated with sodium alkoxide, usually we will get ether. That means in place of sodium, I will write alkyl. That means sodium and halogen is eliminated as sodium halide, NaX. In place of Na, I have to write R. So this is ether. So this very important reaction, this is for exam purpose. This the name of this reaction is Williamson's reaction or Williamson's ether synthesis. That means we are going to synthesize ethers by reacting alkyl halide with sodium alkoxide. So these alkyl groups may be similar or they may not be similar. That is, they may be different. Suppose if I take similar groups C2H5Br, C2H5ONA, so that the ether will be symmetrical ether, diethyl ether. If I take different alkyl groups, I will get unsymmetrical ether. So this is Williamson's reaction, very important. Then the last type of reaction is elimination reaction. So I have already said elimination is nothing but we have to eliminate a molecule from alkyl halide. So when this happens when alkyl halide is reacted with alcoholic base. See, in the first reaction we have observed reaction with aqueous base. With aqueous base, the alkyl halide with aqueous base, the alkyl halide gives alcohol, that means which undergoes nucleophilic substitution reactions, whereas with the alcoholic base it undergoes elimination reaction. So elimination means we have to eliminate a molecule from alkyl halide itself. See here. So here I am going to remove chlorine, and from adjacent carbon I have to remove one hydrogen. So HCl, it is eliminated in the form of KCl and H2O. KCl and H2O. This potassium and chlorine is eliminated as KCl, this OH minus, and here hydrogen eliminated in the form of H2O. So this is a very simple example, ethyl chloride, so that we can expect only one product here, that is ethene. If I take an alkyl halide such as 2-bromopentane, in 2-bromopentane, when it is reacted with alcoholic potash, there are two chances, there are two products. One is 2-pentene, one more is 1-pentene. So how these two products are possible means, so we have to eliminate halogen and hydrogen. No doubt hydrogen is eliminated from the second carbon, and hydrogen should be eliminated. We have a doubt whether the hydrogen should be eliminated from first carbon or it should be eliminated from third carbon, because first and third both are adjacent carbon atoms. So suppose if I remove hydrogen from first carbon, I will get 1-pentene. This is the product. If I remove hydrogen from third carbon, I will get 2-pentene. Now which one is major? If we take the stabilities according to thermodynamics, 2-pentene is more stable, hence we can say that major product. Without knowing or without having the knowledge of thermodynamic stability, how to predict the major product means, then we have to follow a very simple rule called Zaitsev's rule. This is also very important. Zaitsev's rule. See here, according to this rule, during dehydrohalogenation, see, D means removal, hydro means hydrogen, halogenation means halogen. That means we have to remove hydrogen and halogen. That's what we have done here. We have removed halogen and hydrogen. That process in simple manner, in a single word, we can say dehydrohalogenation. During dehydrohalogenation, if more than one type of beta carbon atoms are present, beta carbon is nothing but the substituent carrying carbon is called alpha carbon and the adjacent carbon atoms are beta carbons. So I have more than one type of beta carbon, that means beta 1 and beta 2. Two beta carbon atoms are there. So if more than one type of beta carbon atoms are present, the hydrogen atom is mostly removed from beta carbon containing least number of hydrogens. That means this beta carbon contains 3 hydrogens and this beta carbon contains 2 hydrogen atoms. So that I have to remove the hydrogen from beta 2. So that when I remove the hydrogen from beta 2, I will get 2-pentene. This is the major product. So this is according to Zaitsev's rule. So this is about elimination reaction. Then Woods reaction. What is this Woods reaction? It is already, I think you have already studied about this Woods reaction in the first PU itself or in the 11th standard itself. That is, alkyl halides are treated with sodium metal in the presence of dry ether to form a higher alkane or hydrocarbon. That means I have to attach these two alkyl groups. See here. These R and R dash may be similar or they may be different. If they are similar like this CH3Br, CH3Br. So that if I join these two alkyl groups, I will get ethane. So this is called Woods reaction. So this completes the chemical properties of alkyl halides. So I will glance once again here. Chemical properties. The first one, actually the alkyl halides undergo nucleophilic substitution reactions and elimination reactions. The first one is reaction with sodium hydroxide, where we'll get alcohol. With moist silver oxide, again we are going to get alcohol. With alcoholic silver cyanide, I'm going to get isocyanates, whereas with alcoholic potassium cyanide, I'm going to get alkyl cyanates. With silver salts of carboxylic acid, we are going to get esters. With alcoholic potassium nitrite, we'll get alkyl nitrites. With silver nitrite, we'll get nitroalkanes. With sodium alkoxide, so in which the name of the reaction is Williamson's ether synthesis or Williamson's reaction, where alkyl halide is treated with sodium alkoxide to give me the ether. Then elimination reaction with alcoholic base. With alcoholic base, elimination takes place. With aqueous base, nucleophilic substitution takes place. So with alcoholic base, we'll get usually alkenes as the products. In case of we have different type of beta carbon atoms, then the reaction follows Jacob's rule. So for example, 2-bromopentane, in which 2 pentene and 1 pentene are formed as the products, in which the major product is 2 pentene according to Jacob's rule. Finally, Woods reaction. So alkyl halides are treated with sodium metal in the presence of dry ether to form an hydrocarbon. So this is about chemical properties of alkyl halides.